I'm kind of biased. Okay. So I was going to ask you, like, the Family Feud where, okay, everybody, tell me what you think the tips for success are. If you were going to tell a student how to be successful in any class. But I thought, nah, I'll just go ahead and put mine up. Okay. So how I think you can be successful in any class is kind of up here. Okay. Study. Okay. Pay attention. Do your assignments. Okay. Make sure in this class in particular you get those labs done. If you have any questions, keep me posted. Early labs are awesome. And then have a good time. I mean, yeah. Okay, so just a little bit about myself. My degree's in chemistry, which is chemistry and astronomy, physics. Those are all physical sciences. They deal with the most important things, I think. We contrast that to the other biological sciences, which are important too. So what do I like to do? I like to be outside, so this job works great for me. And I do play the French horn, so like I am fortunate to be part of the Southeastern Iowa Symphony Orchestra. I don't know if you're, I know, it's a pretty good orchestra.
My dentist is a big fan.
Yeah, see? And Bob McConnell, the conductor, is awesome. So if you hear me like humming this orchestral music, it might be from that. So we have 3 kids actually, but only one is left at home. I can't believe it. Our middle child got married on Sunday. It's like, oh. So I know. All right. Okay, and I'm not going to belabor this, but here's a list of things not to do. And I think I mentioned this before. When we're talking about etiquette, just kind of the standard. Did I tell you guys though, if you are kind of sleepy and stuff, I'll just kind of try to communicate to you, just go sleep somewhere else just a little bit. So, but anyway, now we're on to the slides that you have. I'm going to kind of darken the lights so we can see this. Okay. There's lots of stuff up in the nighttime sky. But these are things that you can only, I guess even at the observatory, which is awesome, I think. The observatory, you will not see this through the telescope. This is actually a view that was gathered by the Hubble Space Telescope. And those lights are not stars. Those lights are all individual galaxies. So cool. I think one of the first things, and we're going to see it in the next chapter, that Hubble did actually was to find a blank part of the sky. Okay, the Hubble Space Telescope, if you don't know it, is actually a floating telescope in outer space, but it's tethered to the Earth, so it orbits the Earth. Okay, and the Hubble Space Telescope, one of the first things it was supposed to do is find a place somewhere near the Big Dipper that there was nothing, and it started to find these things. Okay, so these are galaxies, and so what I want to do and what your author does in this first chapter is to kind of talk about celestial bodies in general, a galaxy, kind of put it in perspective. Because this is a survey course, we'll talk more about galaxies. Okay. But one of the things we'll talk more about is our system of planets. Can you see kind of the rings are all orbits of the different planets, our system of planets, as they are tethered or orbit the sun. So there's the sun in the middle there. Okay. And we even included Pluto here. So our collectively we call that the solar system. You don't have this slide. This slide is actually, the source of this slide is down here at the bottom. And that source is heavens dash, not an underscore, heavens dash above.com. So it's a website. And in addition to this sort of information, they are great at, if you're interested in finding this International Space Station, the ISS, that website, heavens-above.com, and we'll be talking more about it. We'll give you how to find the International Space Station. But I like this because it tells you the current position of the planets. Sounds like we're getting back into astrology, doesn't it? Okay. This little box right here has to kind of focus in on the planets that are closest to the sun. Okay, so there are 4 planets close to the sun, and so they're right here. The yellow is the sun, okay. The green one is Venus. Sorry, nope, the green one is Mercury, sorry. The white one is Venus. The blue one is the Earth. The red one is Mars. And then here we go with Jupiter, Saturn, Uranus, Neptune, and Pluto. Okay. So I'm just kind of taking a bird's eye view at different things. So this is the solar, what we call the solar disk. It looks a little hazy, but there are definitely telescopes that all they do, they're special for the sun. There are telescopes that are orbiting the Earth that just look at the sun. Thank goodness, because we need to know what she's doing. Okay, this is a close-up of the sun's surface, and let's see, I think October, November, we're going to have a sun lab. Primary dates in October, the secondary dates in November for our sun lab at 11 a.m. over there. And hopefully there will be some sunspots out. We'll be able to see sunspots. But this is a close-up of sunspot, of a sunspot. And if I could animate this, it's really kind of creepy. See those little, can you kind of see those little cells? Okay, those are granules on the surface of the sun. And hot blobs of plasma come up and then they fall down. They come up and then they fall down. It's really kind of creepy. This is just to kind of emphasize the fact that the sun actually goes through cycles. And if you've kind of been following the geek news, the news about the sun is, like a lot of things, scientists are scratching their head because the sun is kind of, its activity is surprising scientists. It really should have ramped up or be ramping up to a lot of activity right now, and it's kind of not. So I'll talk more about that. All right, a couple of the planets, a couple of the 8 planets, right? Mars and Uranus. Now, we are, and I'm going to go ahead and touch on a little bit right now. I'm going to turn on some lights. I do want you to know about Pluto. And I'm getting, this trash can is going to be the sun. Okay, there's the sun. Bless you. Okay. Back in, prior to 2006, I want to say that time's right. Prior to 2006, the planets, they really didn't have like a Webster's definition of what a planet is. Can you believe that? 2006, right? So, I guess they just thought, well, everybody knows what a planet is, right? But in science, we need to be concise, and we need to communicate. So we are not just, we're in this world together. It's like a worldwide thing. Scientists collaborate all the time. So what happened in prior to 2006 was that there was an astrophysics graduate student who needed a project, and he had a cool telescope. And he said, my project is going to be to look past Pluto and see what's out there. Okay, so I'm going to go over here. There's Pluto over here. Okay. Now, the thing about Pluto is it begins what I usually call crumblies, okay? After Pluto is something they knew already called the Kuiper Belt. Okay, here's my crumblies out here, and here's Pluto. It's kind of the beginning of the crumblies. These things out here most resemble comets. They're kind of like comet-like material. And if you're familiar with what a comet is, it's rocky and icy. That stuff out there. So the dude knew he was going to find, he's just like, I just want to, okay. So lo and behold, he tracked out here an object he called Eros. Okay, Pluto, Eros. Okay, and Eros is larger than Pluto. Okay, and it's very similar to Pluto. Pluto's icy. Pluto's an icy, rocky thing. Okay, so he's like, and if you read, if you hear what this scientist says, this grad student says, he's like, I felt bad calling it a planet, but that's all I could do. Okay, so it was our 10th planet temporarily. So then but he knew what would happen. The reason he felt kind of bad is we call this a planet. Guess what? I'm going to get my telescope out, and you're going to have all sorts of planets out here. Okay, and there goes that would just be a mess. So in 2006, the folks that make such decisions make Webster's or definitions. The folks that make scientific definitions regarding astrophysics, astronomy, got together at a convention and decided to come up, and it took them probably more than just the convention, but they came up with a definition of what a planet is. Okay? So if it doesn't, if an object fails any of these three, then it's not a planet. So the whole spherical part is if something's massive enough and been around long enough, the mass and actually gravity of the object itself kind of crushes it down into a sphere. So it's kind of a mass criteria, being spherical. It needs to orbit a star, okay, which Pluto orbits spherical and orbits our sun. It's a star. But Pluto failed the last criteria. And it kind of goes back to, I go back over here on Pluto again. Okay. In Pluto's groove, as it orbits the sun, are leftovers, crumblies. Okay, so this is significant because if an object has crumblies in its orbit, as it orbits the star, in our case the sun, then it really, we're going to use the word accretion, as the process of forming a planet. It really didn't finish the job. It's just kind of a bit, one bit out of lots of bits in the same groove. Okay, its orbit. Okay, so Pluto failed that criteria. So did Eros, which, by the way, the Eros is the Greek goddess of strife. Okay, so he knew, that grad student knew it would be terrible. So with this new definition, Pluto is no longer a planet. But Pluto is a dwarf planet. So that's a good thing. And I'm thinking this is right. There are 3 dwarf planets so far. Pluto and the troublemaker Eros. And an object called Sirius that we've known for, I'm going to put in asteroid belt. We've known Sirius is there for a long time. And if some of you already know when I say asteroid belt what I mean. But if I go back to here, here's the sun, and we have those 4 inner planets, Mercury, Venus, Earth, Mars. Okay, then we have a belt of crumblies again. But these aren't icy, okay? And one of these leftovers is actually a spherical object. It's the biggest member of the asteroid belt, Sirius. Okay, and it's also a dwarf planet, so I know. It's funny if you listen to the saga, people being so upset. I don't blame them. All right. So unrelated to definition of a planet, one of the things I'd like you to know, if you haven't already kind of pondered this, is here on Earth, the way we see any of those beautiful planets we see in the nighttime sky, which I hope this semester you get to see some planets through a telescope. You just really have to. It's just like, oh, seeing Saturn through a telescope, you're like, really? Anyway, the only way we see a Saturn, the only way we see a planet is it doesn't shine on its own. Okay, it's not like a star. The only way we see a planet is if light from the sun hits that planet and then that light comes back to us. I know it's a small thing, but I'm like, wow, that light did a lot of traveling. Okay. So I have just kind of some pictures of the planets. This purple hazy looking planet over here, this is Venus, and it looks kind of hazy, and we know that Venus has a lot of clouds. But its cycle of precipitation is different than ours. That's like clouds of sulfuric acid. Okay, so, and we have actually, the Russians chose to land on Venus, and we chose to land on Mars. Go figure, I don't know. But they actually have successfully landed, I can't remember what the name of it is, on Venus and sent back pictures. And then it promptly died. Okay, so there's Venus taken in the ultraviolet region of energy, and this is Mercury. Mercury's kind of been in the news lately we're learning new things about Mercury. So one of the things I want you to know from this course, and we'll talk more about it later, is that if we call these inner planets, okay, we call Mercury and Venus our inner planets. Why are they inner? Well, because they're inside our track. Okay, so Mercury, Venus is inside our track. You're only going to see them close to the sun. If you kind of picture them orbiting the sun, okay, you're only going to see them kind of close to the sun. Compare that to Mars and Jupiter and Saturn, Uranus and Neptune, they can go all the way around, okay, from our perspective. They might be close to the sun, they might not be, okay? But from our perspective, we're only going to see them close to the sun, which means that they're only going to be near sunset or sunrise. All right. So this is a moon. It's not our moon, okay? It's very different from our moon in general. This is one of the moons of Jupiter. And you've heard of Galileo, probably. Galileo did not invent the telescope, but he used it to look at stuff. And Galileo used the telescope to see this moon orbit Jupiter. So, and it's cool because if you look at Galileo's little notebook, his little scientific notebook, he shows sketches of Jupiter, and then he shows, actually there's 4 of them. He shows 4 of them orbiting Jupiter. So that's kind of cool. So this is one of the 4 Galilean moons. It's Ganymede. But the other day someone said, well, and I understand why they'd ask this, does a criteria for something to be a planet, does it have to have a moon? And the answer is no. Mercury and Venus don't have moons, but from there on out, I guess we all have moons. Some of them prettier than others. So this is the Earth's moon, and we'll talk more about how this works. But this line is drawn here to show you, and I'll go ahead and kind of annotate it on here, to show you what we call the near side and the far side of our moon. Okay. Anybody in here see Apollo? Was it Apollo 13? The one, not the science fiction one. Was it 17 though? I think, was it 13? The science fiction one where it's the rocks people on the. Well, anyway, a science fiction movie out there that talks about astronauts landing on the moon. And they go explore the far side of the moon. This is the side of the moon that we don't see from Earth. I'm going to talk about why that is. Okay, but there's a side. Doesn't it look all pocked? And that's on purpose. This side that you kind of see part of, and it would continue on around, this is what you're used to looking at. Those dark regions, those non-pocked regions are called mare. They used to think they were cheese. No, they used to think that they were seas. Sort of like cheese. Mars. What can I say? Okay. Mars is like the star child of astronomy right now. We have it's not space junk, but we have so many, well, we have had important rovers roving around on Mars. Okay. We've still got 2 very important rovers. Have you heard of, the latest one's Curiosity? That cool? Oh my gosh, I cannot believe how they got her there. So Curiosity's roving around, sending back images. Every once in a while, they'll send back an image, and we're like, oh, that looks like there's like some sort of life or activity. No. Okay, so Curiosity's there. Spirit and Opportunity were kind of twins sent up shortly after each other. Spirit got stuck, and its little solar panels aren't ever going to work again, but Opportunity is still roving around. In addition to that, we have all sorts of aerial spacecraft orbiting Mars. So you think we're interested in Mars? Yeah. All right. So we talked about the inner planets, asteroid belt, and then we have, beginning with Jupiter, gaseous planets. Okay, so we have Jupiter and Saturn. I was just listening this morning to a geeky podcast, and they said that, anybody know what this is? It looks like a hurricane. It's the Great Red Spot. Have you ever heard of the Great Red Spot? And it looks like a hurricane, and it's getting smaller. It's kind of diminishing. And here's Saturn, Uranus, and Neptune. So beginning with those big guys, okay, they are gaseous. If you were to go stand on them, you couldn't stand on them like you can stand on Venus. They landed spacecraft on Venus. You can definitely stand on Mercury. Of course, we can stand on Earth. You can stand on Mars, but you can't stand on any of these gaseous planets. All right. Then on to Pluto. It's an object. What's the name of the object, though? It's not a planet. Yeah, it's a dwarf. It's a dwarf planet. Yeah. I've also heard it called a Plutoid. So, Pluto. And Charon is one of Pluto's moons. Charon is its biggest, closest moon. But since this, they have, I want to say, found 4 more moons that are orbiting Pluto. And, dun, 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 on its way to Pluto is, let's see if this will come up, a spacecraft called New Horizons. NASA is great at communicating. I think they have to be. Job security and all. So here's their website for New Horizons. Okay, and you see that it's less than a year. Counting down, July, middle of July, New Horizons will have its closest approach to Pluto. Pluto and its system of moons, satellites. So that's exciting. Let's see. Okay. So I pull out a few things from your textbook. Every once in a while, I'll include because I look for something to like test you over in a few weeks when you have your Unit 1 exam. And one of the things I think is interesting is the relative sizes of the star and, for instance, the Earth. And here they are. If our star or if our sun was the size of a grapefruit, okay, the right answer would be very small, if the size of the Earth, relatively speaking. So, since not everybody's been to that green thing right there is DC's mall. Okay, not everybody's been there. So, but the sun is very big compared to the rest, and we'll talk more about relative mass and relative size of the sun to the planets. Okay, switching gears just a little bit. Okay, stepping out from our system of the sun and the planets to the body, the organization that our star is a member of, called the Milky Way Galaxy. Okay, the Milky Way Galaxy. You're going to see some pictures here in a minute. We have never been above our galaxy to know that our galaxy is a spiral galaxy, but we really think it is for various reasons. So I'm going to play you a little video. Anybody in here watch Through the Wormhole? Okay. Morgan Freeman? You remember Morgan Freeman? Yeah. He has a passion for science, and so he's got a series out there called Through the Wormhole. Let me get some sound here. It's going to do a commercial first anyway.
They say rock music makes termites eat wood fast. Is this a scientific fact or scientific fake? But let's find out. We're going to give these microscopic groupings their very own private hotel. They're going to have music all day, all night, with a little snack to help them enjoy it. Now, the termites over here are going to be headbanging to heavy metal.
There you go.
Everything from postpone to rifle. Don't ask me what those are. And the termites on this side are going to be listening to the wheel and So, Death Toll, the Harp Twins. Speed metal.
This is also on that playlist of videos for this chapter.
Our own cosmic voyage begins here, in the center of Galileo's Venice, St. Mark's Square. Since the universe is a big place, we could easily get lost. So, we'll need signposts to give us a sense of scale. The acrobat's ring is 1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. With every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy.
Road trip.
6 steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home in space. Eight steps on our outward journey, 8 powers of 10, and we pass the farthest reaches of human travel, the moon. If we visualize the paths that the 9 planets take in their orbits around the sun, at 13 steps from St. Mark's Square, the entire solar system comes into view. And with 15 steps, 15 powers of 10, we can see that our sun is just another star. From here on, our voyage will be measured in light years, the distance light travels in an entire year. Only now do we fly past our nearest neighbor stars, almost 5 light years away. The same journey at the speed of today's spacecraft would last 100,000 years. As we cross the perpetual night, our voyage takes us up and out of our sun's neighborhood, near the edge of a great pinwheel of stars. The Milky Way is actually a spiral galaxy, and our own sun is just one of the 100 billion stars in it. At this immense scale, 23 powers of 10, each shining light we see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding. Our own galaxy and all the others form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know.
He does such a good job. I approve. So this next slide kind of basically shows you what Morgan was talking about. Morgan Freeman, that is. Putting things in perspective, there's a lot of steps between our little blue dot and the rest of the universe. Okay. Whenever you see the universe depicted like this, each of these dots is probably represents a cluster of galaxies. So it goes planet, solar system, galaxy, okay? And this right here is a cluster of galaxies. We're in what we call the local group, okay? And this right here is a supercluster of galaxies. You would think they would come up with something cluster and supercluster, but that's kind of the differentiation there. And then this is like the fabric of the universe. It's amazing. Okay, so speaking of our galaxy, okay, the one there on the right is an artist's rendition, like it says, of our galaxy. We've never been like a bird's eye view of the Milky Way galaxy, but you're going to see some other photographs of galaxies, and there definitely are some spiral galaxies. The thing about spiral galaxies is you can kind of see the spiral arms. It's a little fuzzy, doesn't it? But the spiral arms are kind of dense population of stars. Now, we do see our Milky Way galaxy, okay, when we look up at night. The map I gave you, the star map the other day for August, okay, it has a place called the Milky Way. And I know some of you guys have enjoyed looking at the Milky Way before, something called the Milky Way. It's called that because it looks like spilt milk. And if you take binoculars and honestly look at the Milky Way, you'll see like stars, like just crazy stars, binoculars. So what that band, and it goes from horizon to horizon, and different parts of the year it'll be different parts of the horizon. But it goes from one part of the sky to the other part of the sky. You are actually looking into the disk of our galaxy. Okay, so we're just like on the Frisbee, and you're looking into the plane of the Frisbee when you see the Milky Way. Best way to see the Milky Way, obviously, is dark skies, moon's not there, no light pollution. So celestial objects kind of fall into categories. There's a general, and when I say celestial objects, I mean like stuff out in the sky, right? I brought a poster. I'm going to go ahead and leave it up here for a while, but each one of these boxes is different stuff you can see up in the sky. One category of stuff you can see up in the sky is called a nebula. And I'm going to show you, this actually is a close-up view of one part of the constellation Orion. Everybody loves Orion. Okay, it's like a fall constellation though, so like here in September, October, it'll start to kind of rise. I love Orion, but if you were to look in what we call the sword part of Orion, this is what you see. A nebula, by definition, is, you see it on the next slide, just kind of a region where there's dust, little pebbles, little rocks. And they glow because of the heat and depending upon the color, the element that's being, electrons around the atom of a particular type of element that's being excited. Okay, so nebula, here you go. So that was the Orion region, an assortment of nebula, actually. Okay, but nebula in general is basically, and it's between stars, so we call it interstellar, between stars, okay? Here's another nebula, blobby. Doesn't it look blobby? So there's a broad type of nebula called planetary nebula. And so planetary nebula is the broad type. I'll go ahead and write that up there. I don't know if it'll... Okay. That's the broad type, planetary nebula. And these are specific names. It took me, when I first started teaching, I'd had intro to astronomy before, my degrees in chemistry would be like, what do you mean by the Helix Nebula? What do you mean by the Hourglass Nebula? Okay, those are like proper names of nebula that all fall, in this case, under the category of a planetary nebula. There's only one of those. The planetary nebula is general. And the reason they call it planetary nebula is because some of them, we'll just kind of pick on this one, if you catch it in the right light, it kind of looks like it could be spherical, kind of a planet lookish, but it's not. Nope, we're going till 50, so don't pack up yet. But planetary nebula all have something in common, and that is, I don't know if you can see, they have a central dying star. Okay, but it's not all bad. The star dies, it kind of sheds its material, and if luck would have it, new stars can be made of that material. So that's planetary nebula. All right. Talked a little bit about galaxies, the Milky Way galaxy. This Andromeda Galaxy is the galaxy that's closest to ours. And it's been in the news recently, or maybe it's just the news I listen to. And the Milky Way and the Andromeda Galaxy actually are on a merger course. So the galaxies will combine.
Is that going to be good or bad?
I've heard different things. I think
They've
that
been separate for so long.
right.
what are like the, I mean, what's
I
the
think
consequences?
the biggest consequence, honestly, is even though it looks like the stars, for example, we're seeing a photograph of that other galaxy. Even though the stars look like they're really close together, there's a lot of room between the stars. So it's kind of like one of these. They will just merge, yeah.
Room for 'em to like kind of
Yeah, they will cohabitate. But the scientist I saw explaining what would happen when they merge is it'll be exciting because our nighttime sky will change.
it would be then brighter. Then.
Yes, it will be brighter.
So,
There'll be other stars.
Will they continue merging and eventually pass through one another?
Some galaxies do that. It kind of depends upon how fast they're moving, and I think from what I've heard, they're moving slow enough that they won't pass right through. But some galaxies do that.
I was going to say, if they did kind of pass through our galaxy, what would happen to our solar system?
Yeah.
And it's get knocked off their axis.
Galaxies that do that, the stars are kind of swapped. So you'll find actually stars from this galaxy in this other galaxy after they pass through each other. They kind of swap stars.
we should exchange these.
Yeah, it's like
I like you red, and we like you better.
exactly. Exactly. Stuff you can see up in the nighttime sky. Okay, they're nebula, or galaxies. The other broad type of stuff you can see up there are clusters of stars. And like you can see left and right up here, there's two types of clusters of stars. What they have in common is the stars that are in a cluster were born about the same time. The same stellar nursery. Isn't that fun? I know, little baby stars. But there are open clusters here on the left and globular clusters here on the right. I love globular clusters. They look three-dimensional through a telescope. The thing about open clusters and globular clusters, but open clusters get names. So like if somebody says, I'm going to show you something through the telescope, and it's the duck cluster, okay, it's an open cluster that the stars look like a duck to them. Okay, so they kind of have names, but have you ever heard of the Seven Sisters? That's what this is here on the left. The Seven Sisters, where there's much more than seven, but it's an open cluster called the Pleiades. Okay. So, all right. Well, this brings us to black holes. This is a good place. I have a little video I'm going to kick off Monday with. Okay, because we all love black holes, as long as we're not falling into one. Okay. So have a great week, and nothing's due Monday. But Monday, I really think we'll get through part 1. And I'll see about posting part 2. I need to open to get the slides. Let me know if you have any questions.